In this video, we're going to flip through the section of the algebra textbook that introduces sequences and series. So this is the last chapter in our college algebra textbook. The chapter is on sequences, series, induction, and probability. I teach probability at the start of statistics. So we're going to finish algebra with sequences, series, and induction. But so a sequence is a list of elements. We're talking about numbers. In math, we're talking about numbers, but by definition, a sequence is just a list of elements. You can have a finite sequence or an infinite sequence. So a sequence that has a finite number of terms, so like a sequence with 50 terms, or a sequence that has, just continues on to infinity. You can look at a sequence like it's like this a sub n. This is this notation here, this bracket a sub n, that represents a sequence. So this is equal to a sub 1, a sub 2, a sub 3, all the way to a sub n. So the n represents, it's telling you the term of the sequence. So when n is equal to 1, so you have this a sub n can be written as a function of n. Some expression for n, a function of n. You plug in 1, it gives you the first term. You plug in 2, it gives you the second term. Plug in 3, it gives you the third term. And that's what this is. Here are some examples of some a sub n's. So typically, the sequences we deal with start at n is equal to 1. The first term is a sub 1. But it can be the case where the sequence will start at a sub 0. It could start at a sub negative 3. And again, it could be a finite sequence. It could end at n is equal to 50. Or it could be an infinite sequence. It could never end. Just from n to n is equal to infinity. But you technically can define a sequence from n is equal to negative infinity to infinity. But in most applications, the sequence is going to start somewhere. So you can have a starting n. But n must be an integer. So n is an integer. You don't have sequences where n can be 1.5 or, like a decimal. N is an integer for all sequences. Okay, here they talk about how you can have this is called an alternating sequence. So with an alternating sequence, each term alternates in sign. So like you'll go positive, negative, positive, negative, positive, negative. That's an alternating sequence. And with an alternating sequence, for the a sub n formula, or b sub n, or whatever you use to define the formula, right? It doesn't have to be a sub n. It could be b sub n, c sub n, whatever. An alternating sequence is multiplying out front of the sequence formula. You'll have minus 1 to the n or minus 1 to the n plus 1, or something like that. Like here, it just depends which terms are going to be negative, which terms are going to be positive. So like here, n is equal to 1, 3, 5, 7 will all be negative. Here, n is equal to 1, 3, 5, 7 will all be positive. Okay? Here just shows how you can think of a sequence as a function. It is a function. For every input, you only have one output. That's how you can list the elements. You can't have one input giving multiple outputs, then you couldn't list the elements. And so it's a function. So and also with functions, you can graph functions, right? Well, you can graph a sequence. It's just going to be a bunch of dots lined up with the x values that are the integers. Okay, and so you can think of the idea of, so here's a normal function, but you can get a sequence from this normal function by just replacing x with n, and that's what this is. And then also, so like that's another key difference between a sequence and a regular function. So you can list the elements of a sequence. You can't list the elements of a regular function. So if I state the domain of this is from x is greater than or equal to 1, I could start at 1, but then and list the first element. But then what's the next element going to be? What's element number 2 going to be? When x is equal to 2, when x is equal to 1.5, 1.1, there's an infinite number of values between 1 and 2. So you can't list the elements of an actual function. Okay, sequence is defined recursively. I make a separate video on recursive formulas, but you can write a sequence formula, like an a sub n formula, where a sub n is defined in terms of like the preceding term. So like here, a sub n is equal to 2 times the term preceding a sub n plus 1. So like let's say you plugged in 50. A sub 50 is equal to what? 2 times whatever a sub 49 is plus 1. But you need to say that you need to give a starting term. Otherwise, if I don't have a sub 1 is equal to 4, then if I plug in, like before I had a sub n is equal to some function of n. That's the regular a sub n. So if you give me 50, I just plug in 50, I get the value. Here, if you give me 50, I'll say a sub 50 is equal to 2 times a sub 49 plus 1, but how do I get a sub 49? So you need to give me a term. Usually it's the starting term, but any term. And then from that term, using that term, I can now take any n and evaluate the a sub n. And you might be wondering, well, what's the point of the recursive formula? Why are we adding extra complication? Well, you might have a sequence that is expressed a lot more clearly recursively than it would be using a regular formula, or vice versa. It just depends on it. Like the regular a sub n might be much clearer than the recursive formula. For example, the Fibonacci sequence. So Fibonacci sequence is a sub n is equal to a sub n minus 2 plus a sub n minus 1. So if it was a sub 70, I would say a sub 70 is equal to a sub 68 plus a sub 69. And so since you've got two previous terms, you need to give two starting values. And so here a sub 1 is equal to 1, a sub 2 is equal to 1. Right? This is really gives you, this recursive formula gives you a really good sense of what the Fibonacci sequence is. But you could write this as just an a sub n with non-recursively, and it would probably it wouldn't have any meaning to it. You couldn't look at the a sub n and understand what that means. But here it's really clear. So this recursive formula is valuable for the Fibonacci sequence. So this is the section of the algebra book where they define the factorial. And so you probably know, factorial, you just say 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. 1 factorial is 1, and then also 0 factorial is 1. Factorials are only defined for positive integers. There's no such thing as like 1.5 factorial. There's no such thing as negative 2 factorial. Well, you might, if you type into your calculator, if I typed it in my calculator, negative 3 factorial, it's going to give me negative 6. What it's doing is it's taking 3 factorial with a negative out front. If you type in, your calculator will give you undefined. Okay, so evaluating expressions with factorial notation, we'll do some example problems on this in another video. Okay, we're going to do a bunch of examples. All right, summing terms of a sequence. So we also want to talk about the idea of you have a sequence and you want to sum the terms of that sequence. When you think about summing the terms of a sequence, you're talking about a series. You could have an infinite series or a finite series, which is also, the finite series is also called an nth partial sum. So you could have an infinite sequence and sum all of the terms of that sequence, all the infinity number of terms. That's called an infinite series, and you can actually, there's some sequences where you actually get an actual number. But if you have a finite sequence or an infinite sequence, but you're just summing the first n terms, so you might say, if you've got a sequence that has 50 terms, you'll sum, what is the sum of the first 20 terms? What is the sum of all of it? Sum of all 50 terms. If you have an infinite sequence, you can still have an infinite sequence and say, what is the sum of the first 100 terms? Those are called finite series or nth partial sums. Because the nth partial sum meaning the first n terms. And so they give, so like S sub n, it's the sum of the first n terms of a sequence. Sum from I is equal to 1 to n of a sub I. This is the a sub n. This a sub I is your a sub n. They just substitute the n for an I for the sake of the summation. Because you're summing from I is equal to whatever your starting term is, 1, 0, whatever, to n. So you're going a sub 1, plus a sub 2, plus a sub 3, all the way to a sub n. So it's still that a sub n here. Okay? And then if you're summing all the terms in the sequence, so from I is equal to 1 to infinity, you just put an s, no n. You see, we go from I is equal to 1 to infinity. Okay, and you might have noticed that, well, we have a sub n, but this is S sub n. A sub n is a sequence. So is S sub n a sequence? Yeah, it is. So like if you have a sub 1 is 1, okay, this is a sub n. All right. What I can do is I can say, okay, what is the sum of the first term, the first 1 terms? Okay, what is the sum of the first 2 terms? What is the sum of the first 3 terms? 5 plus 4. What is the sum of the first 4 terms? I have another sequence here. This is a sequence. They call this S sub n. It's called S sub n. It's related to an A sub n. So in the same way, how we'll work problems where we have a sequence, we're given a sequence, and we want to develop the A sub n formula, the function of n. Well, you could do the same thing here. You could have a sequence like this and develop the S sub n formula, and that's powerful to have that S sub n formula, because if I want the partial sum, just plug in. So if I've got S sub n is a function of n. Well, if I want the partial sum, like the sum of the first 50 terms, just plug in 50, right? Like I don't have to, if you have this S sub n, I don't have to, do all this summation. If I want the sum of the first 30 terms, I don't necessarily have to write all this out. I just put S sub 30 into my function. And if I want an infinite sequence, or an infinite series, well, what is the limit of this sequence? Like as n approaches infinity, what is this approach? What's like the infinite term of the S sub n, right? That's not the same thing as saying the limit of the sequence. You see the difference? The limit of the sequence is just what is the final term approaching in the sequence. We're talking about the sum here. So like the sum of the sequence. So if you have a formula for the sum, an S sub n formula for a sequence, then you can just say what is the limit of S sub n, and that's S. Okay, writing a series using summation notation. Yeah, I mean, we just talked about this. Once you develop what your A sub n is, or your sequence formula, then you're just putting that, you're taking the A sub n, putting the summation out front, and just taking the n from the A sub n and making it an I, because you're summing from the starting term to n. If you're starting at n is equal to 1, you put I is equal to 1. If you're starting at n is equal to 0, you put I is equal to 0 to n. This is A sub n just with I replacing the n for the sake of the summation. Okay, properties of summation. Yeah, we're going to do example. I'm going to have a separate video explaining properties of summation and doing example problems on simplifying summations. But the idea is you might have a function, like you might have created a sequence from a function like, you took the function f of x is equal to x cubed minus x squared over 2x minus 5, let's say. And you wanted to create a sequence from this. So you said my A sub n is going to be n cubed minus n squared over 2n minus 5. Okay, and you want to put this into a summation. So now you said from I is equal to 1 to n of A sub I. So you've got right, that's your summation you have. Well, you can take this and use these different properties to simplify this and potentially solve it. Because there's more properties in this that I'm going to go over, but how would you even start to evaluate this? Well, we'll see. You could potentially, you can treat this. You could factor out an I, and you could try and do do partial fraction decomposition or something, or like whatever. Like get this as simple as you can, and then you can use some of these summation properties and potentially find a formula for the summation. Like you could find the S sub n, like maybe like that S sub n, that's like you want to find the S sub n, right? Well, you could list out the first how could you find an S of n? You could list out the first 20 terms of the sequence and then do that, sum the first term manually. Like, do this manually, sum the first term, the first 2 terms, the first 3 terms, the first 4 terms. Do that manually, get another sequence, and then try and come up with a sequence formula. But then that's when we talk about, if you do that, you have to use mathematical induction. We'll talk about that to prove that formula. Or you could write out a summation like this for your sequence and then use the properties of summation to simplify it and also come up with an S of n. So yeah, we'll talk about that talk about all these things in upcoming videos. So I will see you guys in the next video.